Come on, let's go. All right, we're here in automation. This is where I love to be. I love to see this stuff. I get excited when I'm out here, and I want to talk to you a little bit about one of our newest, I'll call it inventions, because it's really something we developed from scratch in-house. I want to take a step back a little bit and talk about vertical integration. We focus as much as we can on bringing things into the facility so that we control our own destiny. What's really important is we used to rely on outside design firms. Now we actually design this automation equipment in-house. We fabricate everything that goes into it. We build it, and then we program it and implement it together. So now we're in the molding room. I want to talk to you a little bit about some of the additional vertical integration. 11 years ago, we had what I would call a small tool room. Now we've expanded it to the point where we can actually build our own tools in-house. So let's talk back about our core competencies and our core values of safety and quality and cost and delivery. If we're molding these and building the molds in-house when applicable, we are maintaining the molds so that we don't have flash. Now we don't have to trim the parts. We don't have to trim the parts, we don't have risk of cutting. So there's your safety improvement. From a quality standpoint, we're reducing the amount of flash or gouging we could have from actually cutting the part. So what you're looking at here is us actually machining part of the new mold that we're producing in-house. So this is one of the small features of our new RV spreader mold that we're building, and just one of the new capabilities that we'll be working on over the next few years. So we're really excited. So we're here to talk a little bit more about social responsibility, environmental responsibility. So I want to make sure that everyone understands we regrind 100% of the scrap or of the runners that are used to produce the parts. We don't landfill anything. We actually take this entire bin, we set this in what we call a holding bin for a shredder. It then shreds the parts into what I would call semi-fine particles. From here, it goes up a conveyor into a metal separator so that no metal can be contaminating our tooling or our machines. From there, it goes into a small grinder, and then through the regrind operation and dust collector, and then it pipes overhead over to the central blending station that we'll talk about later. And what's really neat about this process, not only are we not landfilling anything, but the dust that we collect from the regrind process, we actually send that out to be repelletized and bring it back in. We're making sure that we're reusing everything we can. So I love the fact that it's always exciting for me to talk about we're even using the dust from the regrind process to not landfill product. All right, we're over at the central blending station. We kind of call this the heartbeat of the molding operation. Essentially, this is all of our raw material. We have all of these blenders. Now, it used to be, we literally took a broom handle and we would stir it and mix it by hand in these big buckets, and we'd haul it over the molding machines. Now it's all automated. From these mixers, which is all automated, it then goes over to dryers. Nylon requires drying because it's a hygroscopic material. From the drying bins where it dries the material, it then conveys it automatically over to the molding machines where we then mold the finished part. So again, this is a heartbeat of the molding operation. A lot of automation goes into it and a lot of upkeep, but this is a really critical part of our operation down in the molding department. So if you look here, we've got a series of dryers stemming from a smaller to a mid to a large size. Now with nylon being hygroscopic, like I mentioned earlier, we need a certain amount of drying time to get to the right dew point to make sure that we don't have any scrap on the parts or splay. The sizing of the bins is contingent on the throughput of the material. The larger the bin, the faster throughput of material, because the material needs time to dry before it gets to the part. It's also important to note nylon and glass-filled nylon is very abrasive. Although it results in a really, really solid, really strong finished product, it takes a toll on our molds, it takes a toll on our equipment. So we have to maintain this and pick the right materials. When we talk about our molds, the reason we have to repair them often is because the nylon glass fill will wear it away. That's why we have to do continuous repair to ensure no flash. Now, if you look here at these glass elbows, these are very expensive tempered glass elbows. If I use stainless steel 90-degree elbows, within 30 days, the glass-filled nylon will create a hole in that pipe, and we'll have what looks like a snowstorm. You'll see resin flying out of the pipes like crazy. So we had to go through and retrofit every one of them. There's over 500 elbows in the plant, and we had to retrofit every single one with a tempered glass elbow. This is one of our new innovative designs we've put in place over the last year and a half, 2 years. This is our new two-shot front handle. And we were challenged with a couple of things. The old handle had multiple pieces screwed together, had a foam piece that wasn't very durable, and it was a high cost item. So our challenge was make a low cost, better, higher durability, and more ergonomic handle without any assembly. So that was a very difficult task, but we love those challenges. So what we said is, all right, we'll start from the drawing board. We'll come up with some new innovative techniques, which you see the mold and the rotation, how it happens. Essentially, we mold the undermold, and then this gray area here, the soft overmold, has a secondary injection unit. Once the mold spins, it injects that over the top of the hard shot, and then we end up with a handle that gets molded all in one shot. So we're here in the CNC department now. Want to talk to you again about our core competencies. Injection molding, we've already reviewed some of that. This is our CNC department. So our challenge was this. We get this from an outside vendor. Can you make it at a 30% lower cost with a 30% quality improvement, making sure that we can keep our tolerances even tighter? And the answer is yes. After 9 months of working through it, we're able to actually have a 32% improvement in efficiency and a 30% improvement in the tolerance bands to make sure that we're actually machining a more capable and more reliable part on a piece-by-piece basis. We meet with the operators every single day at all these visual boards. And just for consistency's sake, we have safety, quality, delivery, and cost all right in front of everyone so they know safety is one, quality is 1A. And it's really important that we have this at every line because a group leader every day will spend time reviewing this board with all of their operators and talk about any issues that happened from the day before, from the shift before, so we're all on the same page. So we're here to talk about our engine adjustment process in general. I don't know that everyone realizes we test 100% of our engines. Every single engine gets tested not only to make sure that we're matching EPA and CARB guidelines, but also to make sure that the end user gets a final product that's been run, tested for wide open throttle, for idle, and everything else. And that makes sure that the end user gets a great qualified product in their hands every single time. Now I want to talk a little bit about poke yoke devices. Again, how do we prevent quality issues? One of our big issues, and I'm not afraid to share with you some of our struggles. One of our big issues were that we actually had the wrong pipes going in the wrong boxes. We also had missing warranty sheets. Well, we had a multi-pronged approach to fix this. The first thing we did is make sure that we put light curtains on every single one of the different pipes, meaning that they have to reach into each and every light curtain, and it has to activate all the light curtains to make sure that we pulled from every location. That prevents us from putting two of the same pipe in the box. In addition to that, we have an iterative scale. And what that means is the box goes on, it zeroes out. The unit goes in, it zeroes out the weight. All the way down to a 1 gram warranty sheet it can detect because it's an iterative scale all the way through. So now when this box gets weighed, it's tied the light curtains into this. We are guaranteed to have no mixed pipes and all of the warranty sheets and manuals are in the box. And that's a true poke yoke device where it's not reliant on the operator. It's a process built in to catch any potential defect. So this is a great example of a final assembly poke yoke that we put in place, programmed, and designed in-house. We're over here at Central Palletizing, and what this is basically automated palletizing. In the past, we had people lifting boxes by hand. They would bring them over in a pallet jack. They would wrap the pallets manually. And now what we've got is we're conveying product from final assembly on the other side all the way over here to Central Palletizing, and the robot's picking up a row of 3 separate units and product. They're bringing them over, they're palletizing them, and then they're building that pallet, and shortly after that it goes out and wraps. So not only does this improve safety from an aspect of not lifting boxes over our head, but we've also done something really neat. We've trained our operators who used to manually handle the product to actually learn to run and program this machine. So now we've actually enhanced the internal skill sets, and we've got people that are much more valuable not only to the organization but to their future because of the skill sets they've learned. So I'm over here in finished goods storage in our warehouse, and one of the things I want to mention is how critical space is to us. As we continue to grow and our product demand continues to increase, we want to make sure that we can maintain this building and stay in here. And how do we do that? We utilize our vertical space. We make sure that we do things such as adding corner boards so that it can support the weight, so that I can go 3 and 4 high with these pallets, and making sure that we maximize every bit of cubic space we can in this building. All right, we're back here at Finished Goods Storage. We're also in the shipping dock area. What you're seeing here is product staged to be shipped out the door. And what I want to make sure that it's clear to everyone is we have a lot of efficiencies built in on the assembly side to make sure that we're versatile. We can meet customer demand, but seasons can break earlier. Spring can happen earlier than we anticipate. Fall can extend past where we want it to. So we want to make sure that we have enough finished goods product to catch any spike in demand and make sure we can fulfill customer demand. So it's really critical that we keep enough product on hand to cover those spikes. All right, we're over in our spare parts area. We carry spare parts for every single unit, including units that have been discontinued 10 years plus ago. And the reason we do that is to make sure that we're able to satisfy our end users and their needs for years to come. One of the big investments we've made at Echo over the last couple of years is air conditioning. It's not cheap, it's expensive to run, but it's absolutely essential that the people have comfort when they come in here. It can get up to 115 degrees in here with humidity. And now that we've got it comfortable, people are happy, they come in with a smile on their face, and that's as important as safety and quality. Morale is right up there. And if you're gonna invest in people, you have to invest in things like air conditioning, like safety devices, like quality to make sure that they understand the value and that we care about how they're feeling every day they come into work. And that's one of the things that makes me most proud to work here at Echo. Well, thank you again for joining me on an inside look here at the manufacturing facility at Echo. I really hope that we're able to stress and show you what we value here at Echo. And again, we value our people, we value safety, we value quality. And I'm really looking forward to an opportunity for you to come here in person and see our facility firsthand. And I can't wait for the opportunity. Thanks, everyone.